So domain and range, here are the definitions. The domain of a function is a set of all x values that can be the input of the function. But when you're looking at a graph, you're looking at how far left, how far right that graph goes. The range of a function is a set of all y values that the function produces as an output. And when you're looking at a graph, you're looking at the height of that graph. What's the lowest? What's the highest? What does that cover? Domain and range, there's two types of ways to express that. One is an interval notation, which will be new to you, and the other is an inequality notation, which you should have seen before. So this first graph, parabola, on the left side, that arrow is pointing down and to the left, and the right side is pointing down and to the right. And if we're looking at how far left, how far right, well, there's no limit to how far to the left or how far to the right this is going to go. And so for inequality notation, I'm going to write this. For the domain, I'll put D for domain. Negative infinity, because that's over here, less than x is less than infinity. And infinity is over here. Okay. Which is just saying everywhere between negative infinity and infinity, x will take on some value there. So it's going to take on everything. Or all real numbers is another way to put that. Okay. The range goes from low to high. So you look at the lowest first, and it's going to keep dropping. So negative infinity will be the lowest. But will it reach positive infinity? No, it actually reaches a maximum, which is at the vertex, at a height of 3. And here, because it hits the 3, I'm going to put less than or equal to 3. That actually makes it to that height. So this is saying all y values between negative infinity up to 3. That's inequality notation. Here's how you'd represent that with interval notation. The interval notation is kind of a short way of writing this. So interval notation for domain would be negative infinity, comma, negative infinity, sorry, positive infinity. And shorthand for the range would be negative infinity, comma, 3, bracket, not parenthesis with the 3. Why do you think I'd put bracket with the 3 and parentheses with everything else? Because we have that equal sign. And we have to distinguish, is it equal to it or is it not? And so the notation is, if we have that equal, we're going to use a bracket. If it's just a less than, then we'll use parentheses. Okay. Why don't I use an equal sign on infinity? You'll never get there, right? It's not a number, it's an idea, it's just, you can never reach it. Okay. So for this next one, domain, we're going to work with, we'll do the inequality notation first. How far left? What do you think? What is it? Negative infinity. Using x for the domain. And how far right? Infinity. And for the range, you always go low to high. What's the lowest? Right here, you're thinking about the y-axis reaches the lowest point is negative 4, and it actually hits that, so I'm going to use less than or equal. And then the highest, there is no cap, and so it's going to reach as high as positive infinity. So that's inequality notation. So interval notation, parentheses, negative infinity, comma, infinity. You could put positive infinity or just infinity. Okay. For the range bracket, -4, comma, infinity, parentheses. So try this one. Domain and range for this exponential function. Remember, the exponential function will get closer and closer to that horizontal asymptote, but it'll never reach it. Okay. So knowing that, try the domain and range. So on this one, it's going to keep going to the left. So it'll go as far left as we want. It increases very quickly, but it does still move to the right as it increases, and it'll keep increasing to the right as far as we want. So for the domain, you want to go from -infinity to infinity. Range, the lowest, it's going to go as low as, it's going to get as close to this line as we can. And the line's at a height of -5, but it will never reach it. So I don't want to put equal, just less than, or -5. So it's actually greater than -5. -5 is going to always be less than 1. And so make sure you use parentheses, no brackets on that one, because they'll never reach that value. Okay, how about this line? What domain from what to what? What's that? -infinity to infinity. It looks like the domain's always staying the same, doesn't it? And how about the range? This one's going to go as low and as high as we want, so -infinity to infinity. Okay. So these next ones start to get a little weird, okay? But they help in us understanding domain and range, and so that's why they're here. So if there's no arrow, that means it does not keep going, right? So here, this is as far left as this goes. Whereas this one has an arrow, it's going to keep going to the left. If you have an open circle, that means there's no point there. It just gets as close to that point, but it doesn't touch that point. If you have a closed circle, that means it actually goes through that point. Okay. So here we're thinking about the domain. The furthest to the left is going to be at 1, 2, 3, 4, 5, -5. But because it's an open circle, it's not actually equal at that point. So -5 less than x. And then the furthest to the right is a closed circle. And so that is part of our graph at 1, 2, 3, 4, 5, 6. So that's our domain. For our range, The lowest point is right here at -1, but it's an open circle, so we don't include that. -1, I'm going to use a less than sign. And then the highest point is up here at 1, 2, 3, 4, 5, 6. And so interval notation, parenthesis, -5, comma, 6, bracket, parenthesis, -1, comma, 6, bracket. Yes. Say that one more time. When x is not equal to 2. Oh, I'm sorry. You're right. There's a hole in our graph. I was looking at the min and the max, but it does not exist at x equals 2. So we're going to have to split this up, actually. So when that happens, let me show you. So right here, that's one interval. And because there's a hole in our graph, we're going to have to pick back up here. So it changes a little bit. So let me modify this. Good eye. So from -5 up to 2, or, so that's part of the domain, that's the yellow part. And then the other one would be from 2, what do we say, 6? To 6. And I also made a mistake on the last one. I put an X for the range, it should be a Y. So when you have two intervals, for interval notation, it would be -5, comma 2. This one's going to be 2, comma 6, which is with a bracket on the 6. And for OR, in mathematics, we use the union sign. And so this is what we would see in terms of interval notation. All right, you try this next one. Kind of stay close to working with a partner, but both of you guys do it, and just check to see if you guys agree on what the range and domain should be. Try inequality notation, try interval notation. Just give it a try. Okay, so for this, you want to notice that in terms of the x values, it's broken up again into two intervals, right? We going from left to right, that hole breaks it up, and then we have another interval starting back up at the same spot and ending. So for our domain, the first part goes from what to what? How far left? -infinity, less than x, and then less than or equal? Less than what? Good. That's where the hole is at -2. Or is the word we want to use. And then we pick up where we left off, -2, less than x, less than. Do I have to stop here? No, because it's filled in. You go all the way over to 5. Okay. And then for the range, So range is all the y values represented. The lowest is right here at -1, 2, 3, 4, 5. The highest is infinity. But there is if we think about the height, there's a hole right here in the height, isn't there? Like if I'm going from here all the way up to infinity, should we worry about that hole? And the answer is no, because there are other values. So that hole is at a height of -1, but -1's represented here and all here and right here. And so as long as there's a y value of -1 somewhere, we can ignore that hole. So usually for the range, it gets filled in. But for the domain, the definition of a function is every x value can only have one y value. And so when there's a hole in the graph, it splits up your domain. Okay. So filling in the interval notation, -infinity, comma -2, union, -2, comma 5. All parentheses, and range -5, comma infinity. How many intervals for this one? For the domain? Would we have to break it up into? 2, because of that hole right there. How many intervals here? I heard 2 and I heard 3. There's 2. That's the only hole in the middle. These are fine. Don't stop here or here because they're filled in. So you go, I'll highlight the intervals. So here, 1, 2, there's 1, there's 2. Okay. So domain on this first one here, that arrow is indicating it's just going to keep getting closer to that height, but that's not an x value. The height's dealing with y value, but it will keep moving to the left as far as we would like. So -infinity, less than x, less than, and then that yellow ends at an x value of -2, or pick back up at -2, and then it doesn't, that arrow again indicates it's going down, yes, but it's also going to the right to infinity. For the range, you decide. Be careful. So what's the lowest this goes for the range? -infinity. Not because of this, but because of this arrow, right? So we have to keep in mind, even though it's not drawn that way, this keeps dropping down to -infinity, and don't be fooled by the picture. That's not the lowest point. Okay, so -infinity, less than y, less than, what's the highest point? 5. It's not going to go above this, and it's not even going to reach it. So don't use the equal sign. All right, one last one for domain and range. Think you can do it? You got it done already? Anybody need time to do it? Okay, do it. Do this last one. I'm working with it. Okay. Let me see. Okay. Yeah. See if you have the same thing. Okay. Right, domain furthest to the left is -6, less than x, less than, that yellow ends at x equals -4, or pick back up at -4, goes all the way to the right to that end at what? 7. Okay. For the range, lowest is, you say 4? -4? Like that? Equals, good. We need that equals. And then the highest is, I put equals? Okay. So -6, -4, union, -4 to 7, and -4 to 6. Good job. Good eye. Oh, so right here, but you guys didn't tell me you should have an equal sign there. Come on. All right, so interval notation. Here's just a summary of what we've been doing. Use brackets when you want to include the endpoint. Use parentheses when you do not want to include the endpoint. Always use parentheses for positive or negative infinity. Always go smaller number first, larger number second. And use the union to connect the intervals when there's more than one within the domain or the range. It could happen with the range. We haven't seen that happen yet. Okay. All right, so that's domain and range. We're going to transition now to, we talked about graphing. We did it on domain and range. This next part is on being able to do the opposite of graphing, writing the equation. So if I give you the graph, you give me the equation. And we'll start with the parent graphs, but then we're going to go back to the second pair of notes and look at, well, what if it's not a parent graph and how you do that? Is it cold? It gets hot real fast, so when it gets hot, let me know and I'll turn it back on. Okay. So for linear, all linear parent graphs are in this form. Y equals mx. And we just need to find out what the slope is. And we're done. If it's a parent graph, okay? If it's not a parent graph, it's going to be a variation of that form. All quadratics are in the form y equals ax squared. So all we have to figure out is what is a. All linear absolute value are in the form, let's squeeze it in here, y equals a times the absolute value of x. And where a is, again, a slope of the right-hand side. And all exponential functions are in the form that the ones that we're going to be working with in the parent graphs are in the form a to the power of x. We just had to figure out what the base is. Okay. So for the line, we just look at the slope. If you find 2 points on your equation and count what's the rise over the run, it's going to give you the slope. So what's our slope here? Up 1 over 3, so our slope is 1/3. And so our equation is y equals 1/3 x. For the parabola, there is no slope. So don't count up and over. You get 2 over 2, 2 up 2 over 3, and you'd be wrong. So don't do that. What you're going to want to do is use the point that's not the parent graph point. Don't use 0, 0, because if I plug in 0, you could, but what happens? If I plug in 0 for y and 0 for x into this equation, what's going to happen? I'm going to get a is going to disappear. I'm going to get 0 equals 0, which is true, but it doesn't help me find a, right? So if you do it, and you find out that wasn't helpful, okay? So do the other, pick another point that's not at the vertex, and it'll work out nicely. So this point is at 1, 2, 3, 2. 3 is your x value, 2 is your y value, and so I have y equals ax squared. Got to remember that form, and then you plug in 2 for y, you plug in 3 for x, and you're solving to figure out what a is. So 2 is 9 times a, so a is 2/9. And once you find a, just like we found the slope here, we found m, plug it into that form, you get y is 2/9 times a, sorry, not a, that's a, 2/9 times x squared. Linear absolute value, you can treat like a line. What we did on the parabola will work on everything as well. You can plug in a point, it's just more work. And you have to do that work here. But here we can, because we have that line on the right-hand side, find the slope of those two, using those 2 points, and use that. So here our slope is what? Okay, so if I go up 1, 2, 3, 4 over 2, I get 4 over 2, which is 2. And so then my form is y equals a times the absolute value of x, but we found a is 2. So y equals 2 times the absolute value of x. For exponential, you have 2 points. You're trying to find a. Again, this point is not a helpful point. You could try it, but it won't help you find a. So that's the parent graph point. This is the other point they give you is the one that's going to be helpful. So just like we did with quadratic, find what that coordinate is. So 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8. So that's at 3, 8. And plug in x and y into that equation, and hopefully you can figure out what a is. So here, 8 equals something to the third power. So what to the third power equals 8? 2. And so a is 2. And so we end up with y equals 2 to the power of x. Okay. So that, when you write equations, you have to know those general forms. If you didn't know those general forms, it wouldn't have gone so smoothly. Okay. and then you for the quadratic and the exponential, you have to plug in a point to figure it out. And then for the line and the linear absolute value, you can use slope. Okay. There is a special case, right? Which you should know is what? Y equals -3. Okay, because you pick any point on here, they all have a y value of -3. Okay, that's what that is. So let's try something here. Try the second row. Work through the second row. We're not going to do the third row. We'll do the second row, and then I'll bring you to some translations, and we'll try to write equations with those. Okay. So for the line, the slope you guys saw was -3. Is that right? -4. So you drop down 1, 2, 3, 4, right, 1. Okay, so -4. And it's y equals mx. So y equals -4x. For the parabola, you have y equals ax squared. You got to find a point that this goes through. 0, 0 is not a helpful point. So we pick something else. They give us one at -1, 2, 3, 4, comma, -1, 2, 3, 4, 5. So I'm going to plug in -4 for x and -5 for y. And I end up with -5 equals positive 16a. So a is going to be -5 over 16. And so our equation is y is -5 over 16 x squared. For the linear absolute value, it's in the form y equals a absolute value of x. And a is actually the slope of the right-hand side only, not the left-hand side. And so we find that slope. We're going down to right 1, 2, 3, 4. So that's going to be what? Negative, good. And I said down 2 over 4, so that reduces to -1/2. And so you get y is -1/2 absolute value of x. Okay. And then the last one, again, a parent graph. And we know it's in the form y equals a to the power of x. We're going to plug in 3 for x, 27 for y. You get 27 is something to the third power. And what is it? 3 to the third power. And so y is equal to 3 to the power of x. How are we doing? Okay. So switch now to the end of our notes on translations. Okay, this part right here. This is writing equations. Do you have this or no? Okay. So it's a little, there's an extra step when it's not a parent graph. Okay, the parent graphs felt pretty doable, pretty easy. There's one extra step when it's not a parent graph. So you start with the idea of a parent graph. I'll do PG for parent graph, okay? So our parent graph is going to be y equals mx, because that's a line, okay? But our parent graph has been translated, right? So the parent graph point, the 0, 0, is not part of this graph, and it's been moved, and we get to decide how it's been moved here. We get a little freedom here. It could be moved to the bottom left point that's shown, or it could be moved to the top right point. It doesn't matter. We'll get different forms of the equation, but it's be the same equation. So I'm going to go with the bottom left. Okay. So if this was 0, 0, it's been moved left 3 down 2. Okay, so that's our point. That's we're saying was the parent graph point, but it's been translated. And because it's been translated, we're going to have to rewrite our equation to fit that translation. So instead of y equals mx, it's now going to be y equals m in parentheses. I want to go left 3, so it's going to be x plus 3. That moves it left 3. And I want to move down 2, so I put a minus 2 at the end. So it's a different starting place. And then after that, I just find the slope. And I got my answer. Okay, but you have to factor in that translation. So the slope, you can look at rise over run from point to point. You can use that slope formula if you wish, where it's you subtract your two y values. Difference of the y values or the difference of the x values. And what are we getting for our slope? Up how much? So we can check, so we can go 2 minus negative 2, which is 4. And then 1 minus negative 3, which is 4. So 4 over 4, the slope of 1. Okay. So y equals, and I don't even put that 1 there, I just write x minus 3 minus 2. Okay. You could simplify that and find, negative 3 minus 2 is negative 5, and you can write x minus 5, and that's fine. I'm going to leave it like this because it shows that translation. But, yeah, it is plus 3. Okay, next one, parabola. So the parent graph, what we know about that equation is y equals ax squared. But we know for sure it's been moved. And we know this one we have no choice. With the line, we got to pick which point we wanted to use as a parent graph point. This one you don't get to choose. It's the vertex. Because that's where the vertex was at 0, 0. The vertex has been moved. So this was the parent graph point, but it's been moved how? 0, 0 moved right 4, down 3. So what would our general equation be? Y equals a in parentheses x minus 4. The square goes outside that parentheses, and then minus 3. Okay, so that's what we're going to work with. And then to find a, what do you think we do? Plug in 6 for x, plug in negative 1 for y. Just carefully work through this. Yeah. Yeah, there's a infinite number of representations. Is that what you mean? Yes. But I'm just going to use a point that's highlighted for me. Yeah. I'm going to, since I've made a few mistakes already, I'm going to purposely make a mistake here and see if you can catch it. So negative 1 equals a times 2 squared minus 3. Negative 1 equals a times 4 minus 3. Negative 1 equals a. And so y is 1 times x minus 4 squared minus 3. Where's my mistake? What's that? I made 2 mistakes, actually. You put your hand in. You got one. Which one? Oh, a is -1, so I should put the -1 here. Huh? My other error, yeah. Are you looking at this line? Right here? Okay. Distribute what? Oh, well, if I had a variable there, I would. But because it's a 6 and a 4, I could follow order of operations, which says do everything in the parentheses first. So 6 minus 4 is 2. That's that. I did fine. Yeah, Chase. This is 4 times a, yeah? Nothing wrong with that. Well, I didn't add 3 to the other side. I just went 4 minus 3. Okay, that's where we're going. Okay, you can't do that. You can't go 4 minus 3. Because that multiplication, right, 4 times a, that's a different kind of term, right? So I need to add 3 to both sides. It's just a common mistake. That's why I did it. So add 3 to both sides. We end up with 2 equals a times 4. And then what? Divide by 4. And so you get 1/2 equals a. And so my equation should be y equals 1/2 x minus 4 squared minus 3. And if you remember from Math 2 honors last year, this puts you in vertex form. Okay. All right. So there's a bit of work with the quadratic. But the line's a little easier because you can skip a lot of this because you know slope. So here, same way. Parent graph, we have an idea. It's y equals a times the absolute value of x. But we're going to have to change the way that looks because the parent graph point is not at 0, 0. It's been translated. And it does matter which point we use. We've got to use that vertex. Think you can do it? Try it. Okay, so you should get y equals 3 times the absolute value of x minus 4 plus 2. So you start with the new translated form, and then you're looking at the slope of the right-hand side. I use the slope equation, but you could use rise over run. You should get 3 over 1. And then the exponential, again, I caution you just be careful with this one because it not translated from 0, 0. Don't forget that. And also, the parent graph point, is 3, 2 related to the parent graph point? I know it's the lowest one, but how do we know? I mean, how do you know it's just not another point that's just lower than the other? Yeah. Exactly. If it's one above the horizontal asymptote, then we know that was the parent graph point that was translated. So this is the point that we're using. For our parent graph, we were working with y equals something to the power of x. But our point 0, 1, which was from the parent graph, has been moved to this other location at 3, 2. So how far right did we move? 3. And how far up? Up 1, not 2. Because it was at a height of 1, and only went 1 more to get to 2. Okay, so careful not to put up 2 and up 1. And so if we rewrite our general form, it's going to be y equals something. We need to find that base. But here's going to be x minus 3 in the exponent, and then plus 1 tagged on at the end. That's our translation part. Then we use the other information given to us. When x is 5, y is 26. And work through that. Look at 25 is equal to a squared. So what's a? You sure? Okay, so if you solve this equation, it could be positive or negative 5. But in terms of this equation, could it be a negative 5? What would this look like if I were to graph that? Well, when x is odd, what kind of answer do I get? Negative. When x is even, what kind of answer do I get? Positive. And so if I were to graph this, just the integer values, it would look like this, like this. It would like split with integer values. And it gets really weird. So we work with our base only being positive. And so we're going to stick with that positive 5. So y equals 5 to the power of x minus 3 plus 1.